Welcome to this demo of the Physician Note Analyzer, which is powered by ChatGPT. Here we'll basically see how ChatGPT can be used to summarize the contents of a physician note. This note could be in an image format where we are using OCR, optical character recognition, and then asking ChatGPT to summarize the notes. We'll also look into the templates that are used and the output that ChatGPT gives. Let's dive into the demo. So now let's look into the demo for this particular physician note analyzer, which is powered by ChatGPT. First, we'll go and upload a physician note. So let's select this note and run this ChatGPT analysis. So this is how the note looks like. And currently ChatGPT would be analyzing this image. It will take some time, but let's look into what's inside this note. So here it's a fake patient, a female patient who has a history of cervifocal venous malformation. We have a comprehensive SOAP note here. So review of systems, past medical history, medications are defined. Here there are no medications. There's a proper physical examination explaining the oxygen saturation level and procedures as well. Now let's see what ChatGPT analysis says that. So what we have asked ChatGPT through the prompt, which we'll see, is that analyze this SOAP note and figure out what kind of diagnoses are possible, potential diagnosis based on this note, and also give the ICD codes and provide an explanation why you think these are the potential diagnosis from the note. And this is the response from ChatGPT. What it's saying is that the patient has a history of condition and has received sclerotherapy in the past. It detects this venous malformation is being present based on the note, and then it starts suggesting the diagnosis codes. So these are the ICD-10 diagnosis codes: Q27.3, 27.8, and D18.1. It also tells why it's suggesting these codes. So these codes are suggested because the patient has this specific condition affecting the skin and subcutaneous tissue. Now I verified some of these codes, and at least these codes are correct. And if you look and compare the analysis done here with the actual note contents, it's fairly accurate. So that's pretty good. Now let's look at another example. So this time we will upload this note, which is about an ER admission. Now let's run ChatGPT analysis for this. So now ChatGPT is analyzing this particular image. It'll take some time. Let's look into what this is all about. So there is a ER admission note. The chief complaint is abdominal pain. The patient is a 44-year-old male who presented this abdominal pain, and symptoms came on suddenly. The pain was not stabbing and it's not worsened by food, and there's a lot of other information. Now let's look into what the analysis says. So same prompt is there where we're asking ChatGPT for potential diagnosis based on this note and the ICD codes which are identified, and also the reason why she thinks this is the correct ICD code. So here we can say that it has identified inflammation of the gallbladder, which can cause sudden and severe abdominal pain. And then it has given these ICD codes: K81.0 acute cholecystitis, pancreatitis potentially, as well as this disease of the kidney, and potentially acute appendicitis as well. So it's kind of like smart enough to figure it out by looking at a note, identify the ICD codes based on its training data, and these codes are correct. I've identified and checked, cross-checked some of them against the ICD-10 website. So it seems to be working fairly good. So now let's look into the backend architecture of this application demo. Here the user accesses this web app and uploads a file. This web app is a simple HTML, JavaScript, jQuery based web application. The web application then uses Ajax to send this file to a backend processing pipeline. This pipeline has multiple stages. In the first stage, the image is taken and the noise is removed from the image. Then the image is corrected for orientation, so skew correction is being done, and then it is fed to an optical character recognition module. The output of this OCR engine is the clinical note, the actual text that's embedded inside the image. This text is then sent to a prompt template where the text replaces the placeholder which is defined out here. So this is the static portion of the prompt that needs to be sent to ChatGPT, and the blue portion is the placeholder where we replace the clinical note text with this dollar note. Once this prompt is generated, then that is then sent to the OpenAI API, which makes a call to the ChatGPT backend, which processes the data based on the prompt that has been given and returns the response. The response is then fed back to the application and displayed back to the user. We can have different types of prompts, not restricted to only one type. This could be dynamically selected as well. So some of the key observations: the OCR accuracy that fluctuates a lot, and that eventually impacts the image quality, which in turn impacts the output text that ChatGPT gets. So this is a very important step to get right. The summarization by ChatGPT is fairly accurate, but obviously cannot remove the human angle. So prompt template injection, it could be of different types. For example, instead of just looking at the physician note and asking for potential diagnosis, we could ask it to find medications or output the past medical history from it, or allergies, or even the risk stratification levels that ChatGPT thinks based on the clinical note. Now, the GPT 3.5 turbo model being used in the demo, its token size is limited to 4K or 4,000 tokens. Because of that, there is a limit into how much data we can send. So the size of the physician note, the text output of that should be less than 4K. And this kind of limits the inference at this point of time. But if we use GPT-4, which has a limit of 32K, almost 8 times, that could obviate the need for managing smaller nodes itself. Some of the use cases include potential diagnosis prediction based on the physician note, then summarizing a very big clinical note to extract the important clinical data from it, like medications, allergies, risk levels, and so on. It could also be used for indirect AMR integration, where the API integration is not possible, and currently there is a human process by which snapshots or pictures of the MR screens are taken and then fed to another system and someone types in. So here it could actually replace that kind of flow. And obviously we could also ask ChatGPT for risk stratification. The key takeaway is that if ChatGPT, which is very generally trained on the all available literature, is trained for a specific domain, in this case recognizing medical notes, it could become more powerful. And definitely there is a lot of scope to improve here. Thank you for looking into this demo.